I think we talked about temporal summation. You remember temporal? Like one action potential occur now, after 2 milliseconds, after 5 milliseconds, after 10, they all get together, summated. This is according to Zaman. Zaman. So because of the time, if summation occurs, it's called as temporal. And if it occurs, see, the temporal and spatial are indicated. One color is over there, you can see. This is subthreshold. I mean, someone was asking a very nice question. I don't know who was about before the class. And so this is the subthreshold when there is no potential, okay? Below the threshold. You know what is threshold level? Where depolarization occurs. So when the summation occurs, see the B, temporal summation. In 2 times, right? 2 times temporal. But spatial is similar to makan. What is the plural of makan? Makana? But in Arabic, I think makan. Huh? No, if 2. Qala, qalu. No, 2, only 2. Makana. And I said makana. And there are many makan then. Okay, good. Thank you, I'm learning. So, makanat, E1, E2, they summate. So, when the 2 spaces they summate, it is spatial summation. But tell me, the spatial summation of this was excitatory, but if excitatory and inhibitory both combine with each other, 2 plus 2, 2 minus 2, what is it? 0. I mean, 2 is this. The other 2 is also this, but the direction of this is positive, this is negative. When they will be added, what will be this one? So see, there is no current. Spatial summation of EPSP and IPSP. Did you get it or not? Yes. So sometime if you are doing some experiment at your higher level, you go abroad for your FRCP or something, you are doing some experiment with humans. I mean, we do experiment with humans, the electrical potential. If you do not find anything wrong, you do not get worried. Because whatever you are doing is excitation and inhibition both. So they are going to summate it. If only excitation, you will see the depolarization. Okay? If only inhibition, you will see that. But excitation and inhibition, if you see 0, it never means there is no work. There was work, but the total sum was 0. Is it clear? And it is with the different signs. You read more and let me know if you find. I think it's okay. It's simple. This is a neurotransmitter. This is now the pharmacological part. Because we were talking, everything is not electrophysiology, electrical. Now see, the electrophysiology is talking in the language of pharmacology. I mean biochemistry, chemistry, language of chemistry. So electrophysiology is not only separate science, but it is combined with other. So receptor is a molecule, and the neurotransmitter is a molecule. They combine, electrical change occurs. Okay? So this type of channels, I told, are several types. Yesterday probably we talked. So generally channels are of 2 types. I mean, there are many types for you. Voltage gated channels. When you change the voltage outside or inside, the channels open. These are those channels that we talk, we walk. Subhanallah, all the channels are not voltage gated. If all were the voltage gated, what was going to happen? Maybe all the time we were jumping a hole. There was no purpose of the creation of universe. So Allah subhanahu wa ta'ala made stabilization. Qayyum. Not only Hayy, but Qayyum. You understand what I'm saying? Hayy and Qayyum. Arabic, you know better than me. Qayyum means so you can give the life Hayy and make Qayyam. Madbut. So this is the reason that the other channels are not voltage gated. Did you get it? So why all channels are not voltage gated? Please tell me. Why are all channels? I mean, voltage gated any time, voltage change, all the channels open. So it means there is no any hard function, no everything will work, nothing. So Allah subhanahu wa ta'ala made different. There are certain channels. If heart has to do activity, acetylcholine has to come. In heart, acetylcholine inhibits. You know? In whole body, it excites. It's opposite effect. Maybe you know or not. Adrenal in whole body, it inhibits, but in heart, it excites. Okay? So you have to remember, we are not talking about her. I'm just talking that if acetylcholine is going to inhibit, so how inhibition will occur? It will combine with the receptor and inhibition will occur. Did you understand? So it means these are not only the voltage gated channel, there is another type of channel. What is the name?
Ligand gated.
Ligand gated, chemically gated, acetylcholine gated, adrenaline gated. These all molecules, acetylcholine, adrenaline, GABA, are called as ligand, or any chemical. So now these channels will open only, for example, if one channel is only for acetylcholine, it will not open if adrenaline will come. Even. So this is the specialization how our body functions, and only specific numbers that are needed for us, like to move my hands, to talk, everything is blessing. To talk, to see, to orient my body. Otherwise, paralysis will occur. If sodium channels, all those are not there. The voltage gated. So all those voltage gated are needed, but inside many other functions are occurring by other type of channels. So the 50 different neurotransmitters for the ligand gated channels. Did you get it? We are talking on this topic. We're talking on this topic. Ligand gated channels, and some are excited, some are inhibitory, and some are mixed. As I talk, sometimes in brain, one part of the brain, one neurotransmitter is excitatory. You will get confused when you will be in a higher level. So be careful, study very thoroughly, because you will see one substance is excitatory, and in other place it is inhibitory. So you have to see which receptor it is, where it combined, type of receptors. So you have to think what is the science of metaphor. Okay? So at this time we do not go into those details, but chemical transmitters, acetylcholine, biogenomine, minus all those you know that, and common neurotransmitter, and very common acetylcholine and adrenaline. And the nerves that bring acetylcholine are called as cholinergic fibers. What called as? Acetylcholine. And the nerves that bring, nerves means axons, bring the adrenaline are called as adrenergic. So on the basis of the neurotransmitter, the scientists coined the name. What is my name, what is your name, but they put name according to their neurotransmitter. Acetylcholine, cholinergic. Similarly, adrenergic, GABAergic, dopaminergic. All amino acids are giving, so we have a large number of nerves. You can imagine how organized system we have. So the common neurotransmitters are acetylcholine, epinephrine, or histamine, GABA. We will talk on this. Glycine, the last lectures, glutamate, excitatory. We will talk on the next week. Now, same story. We have talked that vesicles are broken down. You remember presynaptic vesicles? And these vesicles contain those ligands that are used for the ligand gated channels. And these receptors are like, for example, if they are ligand gated, they may be voltage gated, but voltage gated do not need the combination of acetylcholine and adrenaline with the N channel. They only need the change of the voltage. Is it easy or not? I think you already know it, okay? So, what I am moving my hands, I'm talking, I'm moving body, they don't need any acetylcholine, no, only voltage. So our body has used it. This was the reason John Eccles forgot and he said everything is electrical synapse. Nah. Later people knew, no, chemical synapses are also there and ligand gated channels are also there. At that time channels were not discovered. They only knew, they assumed actually, physiologists mostly assume, because they are mostly philosophers. There should be some pore. Okay, we put the name of pore as the channel. And we say the pathway of channel for sodium, okay, sodium channel. So they were very brilliant. Hodgkin, Huxley, Cards, and many people. Cards was a very, very nice, most of them were in UK. And John Eccles was from Australia. So this is the whole story we already had talked. You can see. Now this is the ligand gated channels. I didn't discuss that. Any question on this picture? Please. This is ligand gated. We talked, but we didn't discuss the channels are voltage gated or ligand. So what are the voltage gated channels? The channels with the help of which we do usual daily life activities without, iradatan, without iradi. I mean, no, I can move my hand, I can move my head, these are nothing. I can put it here, I can take it. These channels are under voltage. What is voltage? No, what is voltage? What is the difference between voltage and current? You must know that. Because when you are studying, you must have very clear idea. See, you say sodium current, potassium current, calcium current. But when you deal whole cell, because you will not understand anything if you do not understand the difference between voltage and current. Because sodium is going into the cell, depolarization. But then you say the membrane potential from minus 90 to minus 80, this is voltage. What it means? Current is going and voltage is changing. Okay, I tell. If you separate, I'm revising you physics of high school. If you have a membrane, in this case it is semi-permeable. If you have a membrane that does not allow all of the ions to, in this case some of the ion can move, but sometimes membrane does not allow any ions. If you separate into two compartment ions, you do not allow those ions to go in and out. But in our case, there are some ions they can go. We will say semi-permeable membrane. Okay. Now what will happen? The ions from the inside will like to, if potassium is more inside, they will like to go out. They will strike again and again. And the sodium from outside, it will strike upon the membrane to go in. Why? Due to diffusion potential. Sodium is high outside in this. So, but they cannot go if it is only membrane. If it is semi-permeable, they can go. Now when they strike, some of them go, but all cannot go. So membrane serves as capacitor. Like the fan, there is no fan, okay. So fan has capacitor. So it separates negative and positive ions. So when the ions will not be able to go in and out, net ions will align. If you see the Guyton book, negative and positive on both sides. And this will be the capacitance of that membrane. So our membrane has huge capacitance. Why? More and more thin is the capacitor, more is the capacitance. If the diameter is more, capacitance is less. So when the capacitance is there, we separate the ions inside and outside. Now the difference of inside and outside current create a change called as voltage. So what is voltage? The difference of current in two separate compartments separated by a membrane create capacitance and create voltage difference. Okay, so now you understand with the help of current how voltage change occurs. This is the reason when we say current go in, sodium is current, potassium is current. This is current, not voltage. It is current, positive current. So current has positive or negative. Don't go into the detail, but at least you try to understand when current go into the cell, change occur in voltage as a whole cell. Did you get it a little bit? A little bit, you got it? You don't need too much. But you must know that current and voltage are different. Okay? But we measure the potential always with voltage. But the people who are playing the game, currents. Sodium, potassium, calcium, all currents. Okay, so when the current is, when the voltage is involved, this is voltage direction. When the voltage is not involved, chemicals are involved. Who are involved? Chemicals. So this is what I talk about. You test with the receptor, all that. Calcium will go in, it will break. We have talked about this. And post-synaptic potential is in the cell. When the neuron body and axon. At that place is axon of Hillock. It has huge number of sodium channels, and this is the reason it is most excitable part in the whole cell. Okay, can I go onward? Any question? I understand it is very difficult concept, but please you read more on current voltage, okay? Because if you like to understand the disorders related to voltage changes, if your future you like to become a neurologist or neuropsychiatrist something, you must have to understand it. But in other areas, maybe gastrology and other things, maybe I think very much. But it's very important for you. Now, these lines are extra. These are not in your course. These just to explain what the definition of inotropic receptor and metabotropic. Inotropic means, see, it's written. Inotropic means when some chemical comes and combines with the receptor. These are the ligand gated. So the reason in the below, inotropic receptor, the ligand gated ion channels form an ion channel pore, but they are related to chemical. Okay, ligand. In contrast, metabotropic receptors are indirectly linked. They are not related to chemicals. It's not that acetylcholine will come and they will open. No. Sometimes some channels do not open until some changes inside. We say second messenger. I don't know how much you know. This is not the topic. The second messenger is activated and through mediation channel opens. It does not open by chemical. So those channels are called as metabotropic receptors. Did you get it a little bit? See, are indirectly linked with ion channel on the plasma membrane of cell through signal transduction. Signal transduction means second messenger. It brings the message. So this is not included in your code. Just read it. Metabotropic receptors are a type of membrane receptor of eukaryotic cell that act through the second messenger. Have you studied second messenger? Yes. Okay, good. So you can know the difference between inotropic and metabotropic receptors. Now we go. Neurotransmitter acetylcholine. What is it? You know that. Acetylcholine is the ligand gated. It serves as ligand gated. And inotropic receptors. Now, inotropic means acetylcholine is of two types. One is nicotinic acetylcholine. The other is muscarinic. When you will study pharmacology and drugs, agonist, antagonist, you will know how they in autonomic nervous system. Don't worry, it's not difficult, but it's not today's topic. A little bit. So, nicotinic acetylcholine is what we say ligand. What we say ligand. Muscarinic acetylcholine is what we say the metabotropic receptors, related to signaling, related to second messenger. Did you get it? So acetylcholine is of two types. If it combines and the pore opens, it is ligand gated ion channel. And if it combines but does not open the ligand gated channel, but through the mediation of signaling, that means second messenger, it is muscarinic. In the next page we will talk. So these terms are okay, because the reason is I am not going in detail. I am talking very little bit, because if I go in detail, more confusion. But your whole pharmacology on autonomic nervous system, you have to understand the meanings and many drugs, agonist and but not now. Maybe in 50, I think. Pharmacology, when you will study. You are studying pharmacology now. You are studying pharmacology. I don't know this system. You are studying nicotinic acid. Do you study? Okay. So more you study from your teacher in pharmacology or come to me. But the nicotinic receptor, inotropic, these are the types of the ligand gated ion channels, glutamate receptors, NMDA, GABA A. Sometime I talked with you and said GABA A and GABA B. You know. So it is not that chloride is related to all GABA channels. No. Only one type is related to the chloride channels. And 5-HT receptors. So this page is gone. This is not included. Okay, children? Don't worry. And if you say, I can say, but you can see this in website. Anyway, what is inotropic receptor? What is metabolism? No need. You are the mature children. You can see from anywhere. No need. If you like, you can take a photo. But if you like, I can send to you. Whatever. Okay, I can send whole pictures again, whole slides if you like. But it is only to 1 or 2 pages a year. Now, see, tell me what is metabotropic. Read it and tell me. Because I explained you the difference between what is inotropic, metabotropic. I need to know very clearly. Like inotropic receptors are those where ligand come, they are related to ligand gated ion channel. And there is no messengers, no nothing. But the other one, metabotropic, where second messenger is involved in the membrane, many other things, signaling other, then they inform and the pore opens. Okay? So these are receptors. You know the receptor. Mm-hmm. So then they open. So these are the two types. Now we read it quickly. Metabotropic, glutamate, or we can say in shortcut, NGL receptors. G protein couplers. These are very important proteins you will study maybe in your pharmacology about many drugs. These are present in membrane. So these are the metabotropic. You have to remember. And similarly, tyrosine kinase, a big topic. In pharmacology, a big, many drugs. We don't go in detail. Guanine, cyclase, and the muscarinic acetylcholine. This is not that nicotinic acetyl. Please remember, this is not that. What is this? This is metabotropic receptor. It goes and combines metabotropic. Okay, then the GABA B. So GABA A was for chloride. Now I didn't talk anything because I didn't like to confuse. If I was going to tell you immediately GABA A, maybe it was producing confusion. Now clear. GABA A was the chemical gated or light gated channel. Okay? No, sorry, this GABA A for chloride channel. But GABA B and most of serotonin receptors are the second messenger, signaling related. And you can say metabotropic receptors and receptors for the norepinephrine, epinephrine, histamine, dopamine. I mean, we don't go into the detail, the type of the norepinephrine, just as a general knowledge. And endocannabinoids. Usually we say cannabinoids. Its definition is here. They are lipid in nature, and they are lipid in nature soluble, and they perform retrograde transmitters. You understand retrograde? Yes. Going from the skin to the mashallah, that's great. You remember that bind to cannabinoid receptors. We have cannabinoids, plants also. So you guide what is metabotropic. We didn't go in details actually. These details are very interesting, but I don't think they're in your course. It goes much in pharmacology. So, but if we get time, you can read yourself, but this is enough for you. Now we talk a little bit about each neurotransmitter and receptor. Biogenic amines, catecholamines, you can read, this is simple. Aminos and GABA. These are just the receptors, neurotransmitter receptor. There's nothing in this way, okay? Just the neurotransmitter, chemical, ligand-gated receptor, okay? And then classification of neurotransmitters, you know that. They are either excitatory, inhibitory, or maybe sometime excitatory, sometime inhibitory, or maybe combined. And beautiful, Jamil way of regulation in physiology and pathophysiology, I will say physiology, is that excitation is added into inhibition. When I say excitation is added, means chemicals are added, okay? Okay, unelectrical. So excitation is added into inhibition to decrease inhibition. Inhibition is added to excitation to decrease excitation. But vice versa, you can decrease to any extent. Okay? This depends upon communities. Yeah, all things. Okay.
By the same neurotransmitter, the neurotransmitter induces the secretion of another neurotransmitter.
Sometimes they serve, the same neurotransmitter serve as a excitatory and inhibitory. The only reason is maybe the receptors are different. It combines with this receptor, it is excitatory. The type of the receptor is different, and now it is inhibitory. Number one. Now your question is different. You say one is the body regulation is if acetylcholine activity is too much, I mean excitatory, body does not stop it through some way. The beautiful way is it adds the inhibitory. Because automatically they know the excitation is too much, it should not be this. It's a feedback system. Okay? So if it is increased, it will be decreased. If it decreased, it will be increased. Okay? It's a positive feedback, not negative. Okay? In hormones, when you will study endocrinology, the negative feedback also occurs, estrogen, LHF, but here it is positive feedback. And your question, one is acetylcholine is increasing excitability. The body will automatically produce inhibitory neurotransmitter. And when inhibitory will make action, excitatory will make action, the result will be this much. Not this, that's the medium. I told you, I showed a figure, how the summation occurs and it becomes zero sometimes. 2 minus 2 is equal to 0. Do you remember at the last slide? So the excitatory neurotransmitters example is there, inhibitory example. Some neurotransmitters are both acetylcholine, okay. I told you, in the body, in skeletal muscles, acetylcholine is excitatory. Okay? Acetylcholine is when it's combined with receptor. But in heart, it is inhibitory. Similarly, adrenaline in the body, in the muscles of body, it is It is inhibitory, but in the heart it is excitatory. So you have to remember cholinergic and adrenergic fiber. It's written here. Is this page is okay? Because if I take too much time, then you will be bored with continuous 2-3 hours. Really, it will be difficult. I understand. And the thing is that you are getting it, okay? And I'm not going in this new system. We cannot go in too many details, right? If we go like 1 hour extra, no, it's not possible. We have to finish because maybe your question will not come from me. They will come from the university or some other source, okay? And if I talk too much and I lose the lectures, it's not good. This is unconcentrated. So we cannot give huge knowledge, okay? The best way is then you come later to me, right? Or Badal class. No, it's not Badal Jama'ah. No, Badal Muhadara. Huh? Okay. So before Muhadara, or anytime you catch me, you see me anywhere, catch me, I will stop. Okay? So whatever is this, what is the class, we start. This page is easy or not? Any question? Any question? Yes.
Works according to the
Receptor. No. If it is in the brain, another area, it is excitatory. But if it is in heart, it is inhibitory. No, that's another thing. This is another thing. The same ligand-gated acetylcholine can have two functions. That's something else. Because receptor is different. When it combines, the nature of receptor is different. One receptor produces excitation, other produces inhibition. So this is written here. See, number 3, some neurotransmitters are both excitatory and inhibitory. No, see that, read that. Some neurotransmitters are both excitatory and inhibitory. Why?
The inhibitory effect in the cardiac muscle works with which receptor?
It's a receptor, a acetylcholine receptor. No, but there are many types of receptor. You can say acetylcholine receptor A, B, like GABA, A, B. There are many types. We are not going in those details. There are many, right? It depends. But you just remember that acetylcholine, when it works in the heart, you usually say cardiac acetylcholine receptor. Mostly we say cardiac receptor. And when you work with neuronal, you say neuronal acetylcholine. Actually, in the brain, there are many. So don't get confused. This is quite enough if you get the idea. Did you get the idea that you need? If you go into many details, maybe dozens of them. So if I discuss, everything will be gone. Oh, you will say, well, what you're talking. And then you get what I'm saying? Very important. But then if you need more knowledge, you can say, inshallah. So any confusion? Now tell me, children, how many types of the neurotransmitter in our whole body? Not only brain, whole body. Number 1, excited. Number 2, and number 3, you got it. It means I'm saying. Now, sometimes, see, it was your question. Sorry, I forgot your name. Slowly. Somebody very famous, so good name. Family probably, yeah? No? The first name was?
Yes, sir.
Okay, you was husband and come back. No, I'm joking. He didn't even listen. You didn't listen what I'm saying? You went for Islam, what should I say, Ahzab, and then you came back. Okay, come back. This relates to your question actually. Your question, I was waiting for this slide. Actually, what happens? Okay, come on, boy. Yes, I'm going to. We were talking much about the postsynaptic excitation and postsynaptic inhibition. You remember? We almost everything we talk postsynaptic receptors. What is happening in post? But something can happen also in presynaptic cells. Potential presynaptic. You understand? It's full of enjoyment. No, you understand? We talked everything postsynaptic, right? Because presynaptic gave us neurotransmitter. It came upon the surface of post. Now, what happens sometime in postsynaptic that we can stop the activity of postsynaptic by presynaptic cells. Yes. And if the presynaptic activity stops, the action will not happen. So how this is called as presynaptic inhibition? Read it. The inhibitory neurotransmitter released by the inhibitory synaptic potential cause chloride influx into the. You know that chloride will go into the cell. Okay, GABA A receptor. Now I can say GABA. They will go into the cell. Now when they will go into the cell, internal negativity will become huge. When it will become huge, no action potential, no function, no shovel. Shovel stop. So this is the way to stop. And if presynaptic inhibition occurs, definitely the post is inhibited, because this is the pre who gives the. So see how it happens. It decreases the magnitude of action potential, no depolarization, reaching the excitatory, then it decreases, no calcium will enter inside the cell. There is, if depolarization occurs, then calcium goes into the cell to break the vesicles. If no depolarization, calcium will be decreased. Similarly, the excited neurotransmitters are released. So this is it clear? So this is only a part related to the presynaptic potential. I mean, how to inhibit it, or how to decide who it is. Now, summation. Summation, it is a very beautiful qissa. I mean, you know already, summation occurs. Spatial and temporal. Now see, sometimes divergence occurs from one source of message spreads to 100 places. Is it clear? Yes. See, the input is over there, is written. It spreads to many cells. For example, there is a stimulus and the body has to stimulate many cells. The stimulus will arise from one cell and it will spread to hundreds of cells. See that? There are two ways. Either one will go into two, both again, two, then four, or otherwise one input will go directly into three and then 1 to 2, and ultimately it will spread. Did you get it or not? Now, but opposite sometimes the activity is in many cells and it has to be summated to affect certain single place, to perform a madboot, madboot action. Accurate and madboot. I mean, collection of hundreds of cells, activity, regulation. Now that is called as convergence. See that input 1, input 2, input 3, and they combine, summated, as you said, according to Makan, spatial, and they will see the output. Similarly, input will spread and then again combine output. I think this is very simple. Is there any problem? Yeah.
Multi-source, single source, what does it mean?
From, for example, one cell makes some regulation, regulates 100. Like I am a teacher, I am regulating whole class. So I am the input. I am giving my knowledge to all. Initially, my knowledge was in my brain, only one, but now spread it. But you all, little by little, something is possible. I don't know many things. You tell me. For example, about the history of Saudi Arabia. I don't know. But every one of you tell me and I know. Okay? Did you understand? All of you give me stimulus in summated form. Oh, then I get huge knowledge. But I'm one. Did you get it? Who asked question? Is it clear? Is it clear? Okay, I think it's simple. And this is the way how the summation occurs in the body, how the regulations occur. Neuronal integration, I think same. This is repetition, though both figures are repetition. Now the other thing is these two terms. Before discussing, I think these words are a little difficult. Okay, this is in your course. But before talking on this topic, you go on next page, you do not have that, but I tell you. This I got from other sources, these are very simple. Take photograph, please, if you can, or I can send it. If you can take photo, it will be good. This is easy language. The notes, things are same, but a little different.
Synapses.
You take now. Now, photograph you finish? No, but if one of you take, you can send to others. Now see, now whatever is in your slide is a very difficult terminology, but you must understand that. Before understanding, you read this. What is reverberating in circles? I taught you in first year, but maybe at that level you maybe couldn't understand properly. It means signals travel somewhere and they again come back to same original place. They come in circle. They regulate some area, they come again back. Well, reverberating. They are making circle, daira. You know, daira. Feedback. This affects this, that's affects the origin. Origin affects the product affects the origin. So this circuit is called as reverberating. The release of this. Read this. Signal travels through chain of neurons. Chain means neuron, chain. They may be in series or parallel, okay? Just like electrical engineering. So, and each feeding back to previous neuron. I mean, it comes here and then back. Then another circle, then back. So, they are affecting each other. An oscillating circle, you understand? Oscillating, making dial. And involved in breathing, sleeping, cycle. Because it's a cycling. You sleep, you wake up. You sleep, you wake up. Then breathing, you bring in and out, whole life. So this is oscillation, continuous dialogue. And repetitive motor activities such as walking. You walk again and again, you stand, then walk, that activity, but this is repetition. Sometimes you walk, sometimes. So all these, did you get it? Reverberating? So the neurons make, we did not go into series and parallel, but there are two ways. Either they get series or they go in parallel. And they go in series means connected with each other. Or they go in parallel together. Sometimes huge number of activities are needed to perform certain activities. We will discuss in that way. Maybe here. Now parallel after discharge. After discharge means when some activities occur. You stimulate and some activity occurs. It's called as after discharge. Usually when epilepsy occurs, initially very little potential change occurs in voltage. We say after discharge. Because this is my area, I used to stimulate the rats. The day I got a little bit, I knew epilepsy is going to happen. So that is partial seeing in animals, okay? Same as in human. But when we study animals, we know better. Diagnosis, symptoms. Because we study animals, we know each and everything. In humans, sometimes we cannot understand. So when a little bit deflection, depolarization occurs, we know soon because we disturb the excitability. We make abnormal pathology. Some disturb. Now after a few minutes it will be like this. Now potential action, potential. So the initial was the partial in certain area, partial the seeing, and later is spread it all. And we say generalizing. Anyways, leave that. So after discharge, you got the meanings of after discharge. It's a potential voltage. Signal stimulates neurons arranged in parallel rays. Okay? One signal, it stimulates the series of the structures that are parallel. 1, 2, 3. Signal is stimulating all. Because the final activity, output cannot be performed only by one. See? So parallel. To make it madhur.
Same in physics.
Same. Whatever is this. No, we are talking normality. Normal. It's young. But that I talk pathology. That was something else. Just to tell you after discharge. But if it is normal after discharge, it's not a case. I was talking about abnormal. Okay? So read it. Signal, Signal, you understand? Message. Stimulates the neuron arranged in parallel arrays. Did you understand? Parallel arrays mean parallel layers. Easy? Parallel. One layer, second layer, they are parallel. You understand? Matwazi. Oh, the word is good. Matwazi. So they are matwazi. And in the other case, series means connected with each other. So that eventually converge. Now you understand the converge, meaning of converge. Converge on a single output cell. One source is stimulating a series of matwazi as well. And ultimately they stimulate a single source. Okay? But becoming first matwazi, many, and then because single cannot do that. You got it? So series of the activities come in common and they become madhbut. You know? If 10 of people of you do work, it will be madhbut. If alone I stress something, I cannot do much. Okay? If there is a rope, I stretch it alone, it's not. If 1, 2, 3 rope is there, and all 10 people or whole class is stretching, it will be easy, right? Did you get it? Yes. So this is parallel signals, this neuron array parallel, that eventually a converter signal impulse reach output cell at different times. But impulse, just one more, impulse, it is not necessary. Meanwhile, one function is performed. After maybe 1 minute, another function is performed. So functions are in the performance. Many functions are occurring. I will give example, you will know it. And causing a burst of impulse. Burst means like 100 impulses came, 10 made this function, 10 made another performance function. So burst of the impulses called an after discharge. And that may be involved, for example, in setting the mental processes, such as you are making the mathematical calculations. When you make the mathematical calculation, cognitively the stimulus in parallel series, parallel form, they go, and it gives you huge knowledge. Because when you are making mathematics, you have to consider many things. And your brain structures are performing activities, and ultimately you do it. And this is done by after discharge, but this is normal after discharge, not abnormal. Okay? This is normal physics. Now, did you understand how the normal after discharge circuit is formed, and how the reverberating means one activity, the source is affecting the product is affecting what happens, and what happens affecting back to the source again and again, like sleeping and waking, sleeping and waking. Okay, what is got it? Okay, good. You will get it more when I go back. But now see, it's very technical. Now see here, reverberating chain of neurons containing collateral synapses with previous neurons in the chain. You understand? The initial affects the later in chain, series, chain, and they affect the original. This is very difficult. And the second is parallel after charge. Incoming neurons stimulate several neurons in parallel. I mean, if this activity happens in parallel. Now you have in detail, so you can understand this. Now, pattern of neural processing. Okay, we discussed it. Pattern, I mean, how activity occurs? Either one structure is combined with the other, with the third, with the fourth in series, and then something happens. Or the other way is what you told, matwazi, huh? Matwazi. 1, 2, 3, 4 structures, they go matwazi, and ultimately that will be called as parallel processing. So series processing, so our brain is actually, much of it is electrical engineering. Bioelectrical engineering, should say. It's more complicated than electrical engineering. So either the serial or the parallel. Is it okay? It's not difficult, children. Because you are studying now, when you will revise it, inshallah it will be easy. But because this is in your course, but I'm not going in more details. If we have 10 classes, maybe we are more able to understand it. But it is only short class, even we have little time. But let go serial processing. Now, input travels along one pathway. I mean, it is connected with the other, third, fourth, and one. You know the electrical circuit, series. So, work in all or none number. The work occurs, it does not occur, for example, spinal reflexes, rapid autonomic responses of stimuli. You understand synapse? When the something happens, sensory action goes there and then goes back. But it is in series. Things are connected with each other. Okay? Chain. And it's written, serial. This is nicely written for processing. A type of cognitive processing which only one item is handled at a given time, and the one step must be completed before processing the other. I mean, it goes like here, one function occurs. It is still continuous, second function occurs. Third, but in series.
One line.
In chain. And the second one is parallel input travels along several matwazi pathways, and pathways are integrated. At the end, they combine together to make it mazboot. One stimulus promotes the newer stimulus. For example, a smell may remind one of the odor and associated activity. When you smell something, you quickly see what type of smell it will be, and you think many things, and then they converge and they give you idea what it is. You know? So this is mental process. And again, this is not in your course. I gave you extra processing of several aspects of problem. I mean, there are many things. You think, oh, this is order. Many things. what might be, which thing I'm having spell. So many ideas together, then you get it. So the processing of several aspects of problems at a time, simultaneously. And the brain's natural mode of information processing many functions, including vision. In opposite, step by step, you remember one function is formed, second function is formed in series. So that is different, and it's called as serial processing, and processing most computers and conscious problems. Okay, so this is, you can think about the brain and computer, the difference, and you read it more, tell me if you don't understand, but these are easy. And this is just an extra summary. Today we studied how the communication in the body, convergence, divergence, synaptic transmission, ion channels, ligand gated, or muscarinic, or the nicotinic style, all those how body communication occurs. That's it. This is today's lecture, and learning objective.